Hello students, today's agenda is to check homework. We'll be learning about bisectors in triangles and you will be able to work on 8.2. Today students will be able to use properties of perpendicular bisectors and angle bisectors to find measurements. And so let's start with some definitions first. So perpendicular bisector theorem says that if a point is on a perpendicular bisector of a segment, then it is equidistant from the endpoints. And we learn in a different unit that a perpendicular bisector is a line that is perpendicular to a segment, meaning it forms 90-degree angles. And actually, even though we only mark one, automatically all four are 90-degree angles. That makes it perpendicular, okay? So that will be this part, 90-degree angles. Bisector means that it cuts the line segment AB into two equal parts. And these markings represent that they are congruent. So that means this has the same measurement as this other segment, okay? It cuts the perpendicular bisector, cuts the segment AB into two equal segments, okay? Again, perpendicular because it forms 90-degree angles, bisector because it cuts the segment into two equal parts. Bi means two, sect is to cut it into two sections, okay? So perpendicular bisector, so if a point is on that perpendicular bisector, this is a perpendicular bisector, so that point is equidistant to the endpoints. That means that if I'm at point C is the same distance to go to B, and from point C is the same distance to go to A, okay? So you can choose to go to A or B is the same distance. So if this is 10, this is going to be 10. If this is 20, this is going to be 20, okay? Okay, the next one is angle bisector theorem. And this is a little easier because it doesn't form two, or it's not talking about two different things. But the angle bisector, it just means that if you have an angle, the angle bisector will cut the angle into two equal angles, okay? And, okay, we learned that as well before, but what do we know about angle bisectors? This is new. If a point is on the bisector of an angle, then the point, let's pretend we're talking about point D, is equidistant from the sides of the angle. So this is equidistant from the sides. This point is equidistant from the sides. If I put another point, then it's going to be equidistant from the sides, okay? So it'll have a little marking in here. Well, this one has similar markings. Okay, or even D, even if it doesn't have any connections, we know that it's the same distance from here to the sides of the angle. Okay, now that we have this information, let's use it to find some excuse me, some parts of the angles. Okay, so if ED bisects AEB, angle AEB, so we're going to have an angle AEB, so AEB, and then it says that ED bisects this angle, more or less. We learned before how to draw, actually, if you remember, with the compass by doing markings and then making that. So ED is the angle bisector. What does that mean? That these two angles are congruent. And I'm going to put two little markings. These two little markings, it doesn't matter if the one is more forward and one is closer to the vertex. As long as they have the same number of little arcs, that means that they are congruent. And so it says that, so that measurement of angle AED is 2x plus 5, and measurement of angle DEB is 3x minus 9. Okay, so in here it says minus 9. So it says find x. Well, knowing that these are congruent, that means I can create an equation because this is equal to this. So we're going to put 2x plus 5 equals 3x minus 9. I start solving. Remember that we cannot have variable terms on both sides, so we're going to cancel the whole term. And so I subtract 2x from this side and I get 0, so I just get the 5. I subtract also 2x from this on this side, so 3x minus 2x is x minus 9. Now to leave x by itself, I'm going to add 9 to both sides, and x equals 14. So that's the value of x. Now it says find measurement of angle AEB. AEB includes this angle and this angle. That means that I need to add the two angles together. 2x plus 5 plus 3x minus 9. I combine like terms and I get 2x and 3x gives me 5x. 5 and negative 9 gives me negative 4. Now I'm going to replace the value of x right there. So it's going to be 5 times 14 minus 4. 5 times 14 is 70 minus 4 gives me 66. So measurement of angle AEB equals 66 degrees. Okay, so that means that this is 66 divided by 2. That's going to be 33 and 33. And you can actually replace it in here and you will see that it does give you 33. So 2 times 14, because x is 14, plus 5. 2 times 14 is 28 plus 5, and that's equal 28 plus 5 is 33. Same here. 3 times x, which is 14, minus 9. 3 times 14 is 42 minus 9, and 42 minus 9 is 33. So you can see that it does come out to be two congruent angles. So it is an angle bisector. Okay, let's do another one. Okay, so in here we have another one. It says if ST is the perpendicular bisector of AB, find the following. So we already know that this is the segment AB. This is ST or TS, it doesn't matter. That's a perpendicular bisector, that perpendicular because of the 90-degree angle, bisector because it cuts it into two equal segments. So automatically we know that any point is equidistant going that way or that way to the endpoint. Okay, same measurement. So this is very simple and straightforward. SA is equal to, Well, we know that this is equidistant to that, so it's going to be 3 feet. Same for TA. TA is equidistant if you compare it to TV, because again, any point on the perpendicular bisector is equidistant to the endpoints. So if this is 4 feet, TA is going to be 4 feet. Okay, very straightforward. Other things that we can conclude is that this is congruent to this. We don't have the measurement, but that will be congruent to that segment. Yeah, I think that's it. And that all 4 angles are right angles. Okay, for this example, remember if a point is on an angle bisector, then it's equidistant from the sides of the angle, okay? So, having that information, we can say that this and this are congruent because F is on the angle bisector. How do we know that this is an angle bisector? The markings. These markings here told me that these are congruent, so this is an angle bisector. Okay, so that means that this point is equidistant from the sides of the angle. And so, to find x, all I have to do is say 8x equals 2x plus 35. I subtract 2x from both sides. 8x minus 2x equals 6x, which gives me 35. And in here, I'm going to divide both sides by 6. And so x is equals to 6 goes into 35 5 times and 5/6. So that will be the value of x. Now it's asking for FB and FD. So FB, I'm going to put 8 times 5 and 5/6. Why? Because it says that FB equals 8x. So all you have to do is just replace the x with the value of x. We're going to put, in here you can just multiply 6 times 5 is 30 plus 5 is 35, which just goes back to this part right here without simplifying it, okay? We put it over 1 and multiply, so 8 times 5 is 40, carry 4. 8 times 3 is 24. So 28 over 6. And if we simplify that, that will be half, will be 140 over 3. And if we want to make it into a mixed number, how many times does the 3 go into 14? Or you can just divide on the side. It goes 4 times and you have 2 left. 3 into 20 is 6, and you have 3 times 6, 18. You have 2 left, 2/3. So that will be the measurement for FB, and we would have to get the same for FD. So in FD we have 2 times x. We already know that x is 5 and 5/6 plus 35. We already know that 5 and 5/6 is 35 over 6. So times 35 over 6 plus 35. We put this over 1, multiply straight, so 2 times 35 is 70, over 1 times 6 is 6, plus 35. In here, you have 2 options. I think since we have a whole number, it's easier to just work with mixed number plus whole number. So how many times does the 6 go into 70? Well, 6 going to 7 once and you have 1 left. 6 going to 10 once and you have 4 left. Over 6 plus 35. These can be simplified because both are divisible by 2. Notice how you're practicing your fractions right now. So this is good. Okay, so it's 11. 4 divided by 2 is 2. 6 divided by 2 is 3. Plus 35. Since we have a fraction and a whole number, you can just add the whole number to the whole part of that mixed number. So you just bring down the 2/3. 1 plus 5 is 6, and 1 plus 3 is 4. So you can see that you get the same measurement for both FB and FB and FD. Okay, same measurement. That means that they are equidistant, so yay. Okay, with this, you're now able to work on 8.2. Just remember that perpendicular bisectors theorem, that a point on that perpendicular bisector is the same distance to any of the endpoints. This is talking about the endpoints, okay? Any point in here, you can just draw any other point and that's going to be same distance here to here, and that's called equidistant. Okay, any point here or on the other side, all of those points are equidistant to either one of the points. And perpendicular bisector refers to line segments. Angle bisector refers to angles, and the bisector cuts the angle into 2 equal parts, but any point is equidistant to the sides, not to one point. Well, it's equidistant to the sides of the angle. Okay, that's the difference. Perpendicular bisector refers to a line segment. Angle bisector refers to an angle. Okay, so now you can work on 8.2 and have fun.